In this section, we take a look at the camera settings and all the related options to cameras in Arnold for Cinema 4D. In this first lesson, we cover general settings and common attributes of cameras in Arnold. Now, we already have a camera positioned in the scene. To create an Arnold camera from the Arnold menu, you can go to Arnold Camera, and now you have access to different camera types that Arnold provides, including cylindrical, fisheye, orthographic, perspective, spherical, and VR. Or you can simply right-click on an existing Cinema 4D camera and add an Arnold parameters tag. And now you have an Arnold camera. Now, before doing that, let's see what native camera attributes are supported by Arnold. By default, Arnold supports some of the settings from native Cinema 4D cameras. One of them is focal length. So let's use a wider lens like 50 millimeters. Or maybe much wider like 25 millimeters. Or we can go to the other side and use a telephoto lens like 135 millimeter. For now, let's get back to around 70 millimeters. Also, Arnold supports horizontal and vertical field of view from Cinema 4D camera. The next supported options are film offset on X and Y. Also, you define camera's focus distance and focus object from here, and Arnold supports them. We take a closer look at camera focus in our next lesson when covering depth of field. Arnold also supports near and far clipping feature of native Cinema 4D camera under the Detail tab. So I can cut off through my render. Let's set the near clipping to something like 600 centimeters. Also enable far clipping and set it to something like 680 centimeters. And now we only see the distance between 600 centimeters to 680 centimeters from our camera, and the rest is cut off. Let's disable near and far clipping and rerun the IPR. Now, to adjust specific Arnold's camera setting, you need to add an Arnold parameter tag to your camera. So right click on the camera, C4D28 tags, and Arnold parameters tag. The cool thing about Arnold parameters tag is that it is dynamic. So based on what kind of object you are adding this tag to, you would get related settings to that specific object. Now, if I select the camera tab and enable custom type, I can choose between different camera types like cylindrical, fisheye, orthographic, perspective, spherical, and VR camera. We discussed these camera types in a later video in this section, but in most cases we would use perspective camera. So let's disable custom type and go to the main tab. The first parameter, which is the most important one, is exposure, and it controls camera's exposure in a non-physical way. So as you increase the exposure by one step, you are doubling the overall brightness of the image without affecting the lights and the shaders in the scene. Now, by increasing the exposure, you are letting more light to enter the lens and therefore getting brighter final results. You can decrease this value, let's say to something like -2. And as we have a smaller exposure value, we get a darker final result. In other render packages, you have a bunch of settings that affect the exposure in a physically correct way, like ISO, shutter speed, and f-stop, and you need to keep the balance between them. But here you have one non-physical control to adjust the camera's exposure. Let's set it back to 0 for now. Filter map allows you to darken certain regions of the image. You can simulate effects like vignetting, for example. As you can see, we can't load the texture directly. First, you need to create an image node. So create one and load this vignetting texture. Now select the Arnold parameters tag that is applied to this camera and drag this image to the filter map field. And now the image is multiplied over our render and we get this vignetting effect. I would never use this here because I can very simply add this effect in Photoshop or After Effects or any other compositing or image editing app. But if you want to use it, there you have it. Let's clear it for now. We have rolling shutter, which is used to simulate the type of rolling shutter effect seen in footages shot with digital cameras that use CMOS-based sensors. Rolling shutter direction specifies the direction that the rolling shutter takes place. With rolling shutter duration parameter, it is possible to control the duration of exposure of the scan lines in a rolling shutter camera. Now let's unhide our abstract object here. And as you can see, it has a simple rotational animation from frame 0 to 10. Let's go to frame 5 maybe. Also in the IPR, let's enable render region tool and just render this section around the object. Rolling shutter is a motion blur related effect, and in order to see how it works, we need to have motion blur enabled. So open up the render settings, on render, and under the main tab, go to the motion blur section and enable motion blur. To render motion blur in the IPR, make sure to enable it using this button. And to see the effect a bit better, let's change the motion blur length to about 3 and keys to 5. Don't worry, we discuss motion blur in this section later on. Now let's see how different rolling shutter direction and duration values affect the overall motion blur look. Right now in the IPR, we just have motion blur, no rolling shutter. Now let's set the rolling shutter direction to top and no duration. You can see the result in the IPR. Next, let's set it to bottom and no duration. Left and no duration. And finally right. Now let's set direction to left and increase the duration to 0.25. As you can see, we get the motion blur itself back and we have rolling shutter going on as well. For now, let's hide the object. We discussed depth of field comprehensively in its own lesson. We have UV remap. For this to work, we need a lens distortion grid and making a UV distortion map from that. And this will allow us to have barrel or pincushion distortion camera lens effects. Radial distortion allows you to simulate a pincushion lens distortion with negative values. And a barrel distortion with positive values. Let's try something like 0.5 for now. Using this radial distortion type, you can choose between cubic and cubic inverse. The last topic I want to discuss in this lesson is this lens tilt and lens shift. For this, let's open up this 0501 camera 02 scene file. And select the Arnold parameter tag that is assigned to the camera and run the IPR. Using lens tilt, you can tilt the camera horizontally or vertically to correct the perspective, particularly in scenes where the camera is already tilting up or down, basically to achieve the simulation of tilt lenses for 2-point perspectives. You can actually use these parameters here, and it is very useful in exterior architectural visualization to correct the perspective. In this render, you notice how the vertical lines of the building are not straight, and if the building was much taller, the effect would have been much more obvious. But if I increase the tilt angle on Y to around 10 degrees for this scene, we straighten up the lines. And if I go overboard and increase the angle to maybe 20-25 degrees, now we get the opposite result. Lens shift allows you to shift the camera view horizontally or vertically without rotating or tilting the camera in both the X and Y axes. We can use positive and negative values here to shift our camera without tilting or rotating the actual camera. And this works exactly like the film offset X and Y in the Cinema 4D camera itself. Also down here we have some shutter controls which are related to the motion blur effect, and we discuss it in the motion blur lesson of this section. So that was a quick look at Arnold camera. See you in the next video.